3i Atlas doesn't do what a comet does. It doesn't pass by. It seems to cling to the Earth-Moon geometry for an hour, like a pre-laid track. The scary part here isn't even the distance. It's something else that's scary. He chooses a window where the moon becomes a natural shield, blocking some of the observations and making the Earth the maximum contrast target against it. From the outside, it looks beautiful and almost harmless. In pictures, the orbit neatly touches the lunar node, as if drawn with a ruler. But inside, in work chats and on private lines, words that are usually not spoken out loud begin to resonate. It wasn't theoreticians who first noticed this, but people who live by schedules. Operators, for whom every minute in their observation grid costs money, fuel, and reputation. They saw in ephemerides not an error, but a choice. Because the lunar node isn't a fancy term. It's a tight geometry, where everything aligns so that one shadow obscures another. Mistakes don't get there. You get there when you know exactly why. At 3:24 a.m., the first signal came from southern Chile. Not a photo, not a spectrum, just a dry phrase. The window is falling through. Too much light pollution, too little clear sky, too awkward an angle. 2 minutes later, the same phrase came from the Canary Islands, then from South Africa. And now, this was strange because the weather was different, but the problem was the same. It was as if they were all standing in front of the same wall. The moon's position at that hour forced large optical telescopes to choose. Either hold the object steady or avoid burning out their detectors with stray light. On paper, this looks like bad geometry. In practice, it looks like a closed door. And it's precisely at this hour that Atlas III settles into a line where Earth becomes convenient for work. Not just as a point, but as a disk, as a system, as a target that provides maximum information with minimal interference. At 3:31 a.m., an internal call is opened at one of NASA's centers. There's no panic, but the tone is dry as glass. They only ask one thing: who saw this first, and how sure are we? The answers come in fragments. Someone talks about a knot, someone about a sharp correction in the trajectory approximation, someone about the impossible purity of the coincidence, and at some point, someone utters a phrase that changes the atmosphere. He chooses his moments. Then comes the part no one likes. Quick checks for self-deception, recalculation, cross-validation, comparison of different catalogs, assessment of taxonomies, all so that we can say, it wasn't us who made a mistake. But the more they check, the worse the picture looks. The possible errors disappear one by one. Only geometry remains, and it's too precise to be random. It's as if logic, not inertia, is holding the course. At 3:38 a.m., a short report from the dynamics team lands on the desk. Temporal capture by node window approximately 58 to 64 minutes. Even the range looks like a schedule. People look at it and remain silent, because silence is easier. Along with the optics, another issue arises: radio. Communication lines with several devices are starting to behave unclearly. Not a blackout, not a failure, simply an increase in noise as if an additional layer had appeared in the space. The layer isn't broad, it's not global, it's local. It lives precisely where the Earth object line passes during those 60 minutes. This is important because random interference doesn't draw geometry that way. At 3:44 a.m., someone mentions the moon not as an obstacle, but as a tool. The moon can block more than just light. It can block radio channels, it can cut out a section of the field of view, it can hide details, and then comes a truly unpleasant thought. If you wanted to do something near Earth so that observers would see less, you would choose exactly this window. You would use the moon as a screen and use Earth as the experimental object. At 3:50 a.m., the people working on the lunar probes are called in. Not because it's interesting, because near the moon, that's their territory. And the first question is simply, do you see anything unusual on your sensors? The answer doesn't come immediately, because the lunar data isn't the kind that's readily available. It needs to be retrieved, compared, and contextualized. But while they're doing that, the team faces another problem. The buzz is already starting on public channels. Amateur astronomers are spotting the object, some are posting images, others are drawing arrows. People are rejoicing at the rare guest. And against this backdrop, closed conversations seem almost absurd. It's absurd until the next line arrives. At 3:57, one of the operators sends a graph showing that the calculated brightness should be increasing, but the actual brightness is stepwise. It's as if the object is sometimes visible, sometimes not. The steps match the way the moon cuts through the observation windows, too smoothly, too neatly, and then you get the feeling that you're not just observing a body, you're observing a pre-written scenario. At 4:02 a.m., another coincidence is placed on the table. At the same hour, several upper atmosphere monitoring networks detect a local seam in the ionosphere, not a storm, not background, a strip that matches the sighting geometry. This isn't about telescopes anymore. This is about the Earth, about its shell, about its reactions, about its weak points. And when all these pieces come together, it becomes difficult to maintain a calm demeanor. At 4:06, someone asks a direct question. If this is a test, then what is it testing? The call pauses because this question can't be answered lightly. Any answer sounds like an admission no one wants. The official position prepared for the press looks familiar. Observations complicated by geometry, no confirmed anomalies. It's a normal, smooth, and safe narrative, but it doesn't match what they see on the inside, because there are already three things inside: the hour of capture at the node, the lunar screen that cuts off the view, and local reactions along the lines that coincide with the trajectory. This is no longer added, it's already built. At 4:11 a.m., one of the call participants quietly and very specifically says, if he chooses a node, he understands the phase of the moon. Understanding the phase of the moon means having a model of the system. And a model of the system is not the behavior of a stone. This phrase doesn't sound dramatic, it sounds professional. That's what makes it scarier, because there's no emotion in it, only a conclusion you don't want to accept. At 4:15 a.m., the lunar data team responded. They saw a brief, odd jump in the orientation of one of the starfield sensors, not critical, but unlike normal noise, and the timing was almost perfect. The jump lasts only seconds, but it looks like a shift in the celestial grid, as if the optics momentarily saw stars in the wrong places. This isn't an effect of the moon or the Earth, it's an effect of the medium between them. At this point, the tone of the call changes. People stop arguing over details and start talking about action. What to raise, what to turn, where to prioritize, which channel to keep clear at all costs. Some suggest using everything they see in infrared, because moonlight doesn't disrupt the image as much there. Others are asking for maximum radar coverage. Even if the data has to be suppressed later, the word coordination is being used for the first time. And here's the final detail that makes things chilling. At 4:22, the dynamics show a trajectory update. Nothing explosive, just a tiny tweak that makes the capture hour even smoother. The correction looks as if the object was slightly adjusted to prevent it from falling out of the node early. Just slightly, just enough to be explained by any number of things, but still enough to maintain the perfect hour. You don't have to be paranoid to understand the meaning. If you want an hour, you hold on to the hour. If you want a screen, you choose a screen. If you want the Earth as a target, you take the moment when it's brighter. At 4:28, one of the participants says, if he's working on Earth right now, then the moon could just be a calibration. A calibration of what? A rangefinder, geometry, atmospheric reactions, resonances, any parameter that can be measured by contrast. And just as they're saying this, a message arrives that makes everyone's throats dry up simultaneously. One of the ground stations receives a brief return of the signal in a location other than where it's expected. Not strong, not obvious, but persistent. Too persistent to be a dust coma. It persists for several pulses in a row, as if reflecting off a structure rather than a cloud, and it's happening right at the center of this hour. No one shouts on the call. It just gets very quiet, because now the story has a question that can't be put out of your mind. If it's a reflection, then what exactly is it from? And why did it appear precisely when the moon blocked half the world's eyes? We stop here, because now begins the most unpleasant part of the moon coupling hour, the part where the object takes the next step, and for the first time, people begin to feel like they're not just observing, but participating. At 4:31 UTC, the return occurs again. Not just once, not as a random burst, but in a series, with the pulse shape barely changing, as if the surface there were hard and stable, not dusty and alive. The radar operator doesn't write the word structure, he writes something else. The signature holds. In their language, that means something simple. It's not a cloud that's reflecting, it's something that doesn't fall apart in the wind, or float along with the coma. At 4:34 a.m., two sites are already seeing this. Different frequencies, different angles, different filtering methods. The main thing is the same. The return stays in place relative to the object, as if glued to it, rather than spreading out along the tail. From this point on, the lunar hitch ceases to be a pretty orbital story. It becomes an operational task, where every minute decides whether people will have proof or just the feeling that proof has been and gone. At 4:37 a.m., NASA orders an emergency window coordination. On paper, this sounds neutral, like optimizing observations. In reality, it means someone will give up their time so someone else can capture important footage. And this is where the moon shows its teeth. It doesn't just interfere with the optics. It distorts the geometry so much that some telescopes are forced to switch to safe modes. Otherwise, the light pollution would simply burn out their sensitive components. At 4:41 a.m., one of the large telescopes on Earth won't be broadcasting anything, but internally they'll display a switching to protection flag. It seems routine until you realize the protection has been activated at the perfect hour. At 4:44 a.m., a group working on satellite data is connected to the call. Not astronomy, but Earth's environment. And almost immediately, a threat emerges that's more frightening than the reflection. The upper atmosphere is behaving strangely. Not globally, not like a storm, but like a thin band of disturbances that appears and disappears along the Earth object line of sight, as if someone is running a scanner across the planet's shell. At 4:48 a.m., they call it a local electron density anomaly, but when they superimpose it on the geometry, it becomes clear why they're so cautious. The band matches too precisely to be simply weather. At 4:51, an unpleasant thought arises and is voiced out loud. Perhaps the object is testing not us as a whole, but our boundaries. The ionosphere as a shielding layer, radio communications as a nervous system, optics as eyes. At 4:54, someone on the other end of the line asks, "Can this be done passively?" It's a valid question, because if it's done passively, it can still be explained. If it's done actively, there's no explanation other than that no one wants to talk about it. At 4:57 a.m., a new packet arrives from the speakers. The trajectory update confirms what we've already intuitively sensed. The clock at the node holds steady, and minor deviations are corrected, as if the object isn't allowing itself to slip. At 5 a.m., someone senior uttered a phrase that cut the air. "We need proof that will outlast the press service." That is, data that could be shown to scientists, even if they publicly said nothing unusual. At 5:03 a.m., they decide to attack several directions at once. Infrared windows, where the moon is less likely to obscure contrast. Polarimetry, to see the structure in the scattering. Radio, to detect the shape of the return. All at once, before the hour is up. At 5:06 a.m., a cameraman at one of the sites records something strange. The return has a breathing quality, but not like a dust cloud. It rises and falls at almost the same rate, as if a facet were rotating. It sounds like a fantasy until a second log from another site appears. It's the same pitch, but with geometric adjustments, and at that point, a very realistic picture forms in people's minds. If an object rotates and the reflection changes in steps, then it's not a spherical cloud that's reflecting. It's a shape, a plane, edges, something that has geometry, not just mass. At 5:10 a.m., someone suggests comparing it to the signatures of known satellites, debris, and large asteroids. Not to tie it in, but to rule it out. A couple of minutes later, they rule out everything familiar because the hold, relative to the comet, is too stable. At 5:13 a.m., another line runs parallel. Amateurs, there are many of them, they're fast, and they don't follow agency schedules. Someone from the monitoring team quietly says, "If our windows are blocked by the moon, amateurs could become a hole in the screen." At 5:16 a.m., they start collecting data from private networks, unofficially, unattractively, through friends, through forums, through those who know how to extract raw footage without compression or auto-correction, and then comes a moment that breaks the usual order. At 5:19, a shot comes from a man who has no grants, no press offices, no right to make mistakes. He just has a camera and stubbornness. In the frame, a point source appears momentarily next to 3 ATLAS. It's not a coma, not a catalog star, not a glint. The point lingers relative to the comet and disappears so abruptly as if it had been switched off. A minute later, a second frame arrives. A different point in the world, a different lens, different air. And there's the same point in the same relative location with the same short lifespan. This is no longer an artifact. It's a coincidence that kills excuses. At 5:23 a.m., the word false star is mentioned for the first time in the call, and it's said as if they're afraid the microphone will pick up the meaning, not the sound. Because a false star means one thing: someone is setting up a beacon. If a dot is held relative to a comet, it's not a star. If it's not cataloged, it's not a random field. If it appears synchronously in two places, it's not a glint. It's a signal that can be turned on and off. At 5:27 a.m., people try to remain cool. They ask, could it be a satellite on the line? And then the moon intervenes again. At this hour, the geometry is such that conventional orbital explanations begin to disagree on speed and parallax. At 5:30 a.m., it becomes clear why the object might need a lunar screen. It doesn't make observation impossible, it just makes it fragmented. You see bits and pieces, but it's hard to piece together the whole because half the world is in shadow. At 5:33, someone offers a hypothesis that sounds eerily calm. It can test our capacity for coherence. That is, whether we can quickly connect different sources, eliminate noise, and extract the truth from the fragments. At 5:36, the stable reflection returns to the radio link, and now it shifts by microlobes, as if its orientation is changing. This appears to be a maneuver, but it's so subtle that it could be called a jitter. And at exactly that moment, the band in the ionosphere intensifies, not across the entire planet, but along the same line. It's as if an object is doing something nearby, and the Earth responds with its outer shell, like skin responds to touch. At 5:40 a.m., one of the specialists said out loud what had previously been left in their heads. If this is a probe, it's not looking for beauty, it's looking for a reaction. A communication reaction, an atmospheric reaction, a reaction from the observers. At 5:43 a.m., the hour isn't over yet, but it's already beginning to close. The moon is setting, the geometry is spreading, the window is becoming less convenient, and it feels like the object is about to either leave us a clue or take it back. At 5:46 a.m., a brief peak is detected on one of the infrared channels. It's not large, but it's clear. It matches the appearance of the false star in amateur footage. It's too synchronous to be coincidental. Then comes the most unpleasant interpretation. The point source may not be nearby. It could be part of an object, remotely located, like a module, a component, or a separate lamp that is turned on to operate. At 5:50 a.m., someone suggests checking the parallax of a false star between two amateur points. If there's parallax, it's close, meaning it's truly in the system. If not, it's more subtle, meaning it might not be where we think it is. They start calculating right in the chat, on the fly, with errors and complaints about the data quality, and the further they count, the worse it gets. Parallax suggests the source isn't at infinity, it's near the object. At 5:54 a.m., the lunar hitch approaches its edge, but the finale doesn't resemble a fade-out. It feels like a click. The radar return drops sharply, as if the surface had been turned away. The band in the ionosphere breaks and disappears, as if the experiment had concluded. At 5:58 a.m., a brief silence falls on the call, in which people can be heard breathing. They understand. If this was a demonstration, it has just ended, and the subject has left, leaving us with fragments. And then comes the last message of the hour, the most disgusting one. The same amateur who sent the false star shots writes that in his next series of images, the core looks different. Not blurry, not in focus. A different shape. That is, while some saw a dot, others saw an elongated structure. At the same hour, in the same window. And if this is true, then the object wasn't simply hiding behind the moon. It was changing what we see. At the same moment that the false star flared up among amateurs, the core suddenly ceased to be a single object in professional footage. This isn't poetry. It's a direct contradiction in the data that can't be covered up with words. In one set of images, the nucleus is elongated, like a short line, as if there were an axis, a body, or an elongated structure. In another, the nucleus is almost a dot, pure and dense, as if all unnecessary details had vanished in an instant. The worst part is that these images have the same basic things. Orientation, exposure, atmospheric quality, even the calibration stars are positioned identically. So, the "you're out of focus" argument doesn't work. If this were a single telescope's error, it would be widely reported within 2 minutes. But here, the error must occur in several telescopes at once, and it must occur in a way that produces different results, but equal certainty. When this happens, science doesn't usually cry anomaly. It does something else. It tries to piece together the big picture so no one can say, "You picked the convenient bits and threw out the rest." That's exactly what they did right away. Raw footage in one pool, no fancy processing, no enhancement. Just the sensor, noise, background, and whatever actually hit the sensor at that hour. 10 minutes later, an unpleasant detail becomes apparent. The discrepancy doesn't disappear even with identical processing. It even becomes more noticeable because the effects of different filters and different post-processing chains are being removed. What follows is something that doesn't usually make it into press releases. The debate isn't about what it is, but about what we have the right to say. Because if you mention the word inconsistency, the world will hear, "We're not in control." A chilling statement appears on NASA's internal channel. An external cause for the discrepancy is possible. This isn't an accusation, but an attempt to explain why objective instruments see different realities. Some propose a banal hypothesis, a dust shield, a localized coma density, microflares that sometimes obscure the core, sometimes reveal it. But this hypothesis has a weakness and everyone can see it. To explain the dot versus stroke difference, the coma must function like a perfectly calibrated mask. Not chaotically, not like a cloud, but like a curtain that sometimes opens and sometimes closes the same part. And here the false star pops up again. Because that's exactly how it behaves. It turns on, aligns with the object, and then turns off. If it's a beacon or module, it could function both as a backlight and as a mask. At this point, the room becomes crowded with thoughts. If an object has a controlled point of light, then it has control over brightness. And for the observer, control over brightness is almost the same as control over form. One analyst puts it bluntly so everyone understands. If he can change the image he presents to the camera, he can choose which version of himself we see. After that, no one smiles anymore. Things get more complicated from here. Radar returns a steady return, optics debate the shape of the nucleus, amateurs pinpoint the point, and the upper atmosphere shows linear bursts of the same geometry. 4 independent lines, each telling its own story. But if you look at them, not as a set of facts, but as behavior, a consistent theme emerges. It all feels like a test of perception. Someone adds another layer, the most unpleasant one. The moon at this hour acted as a filter for observations. It didn't completely obscure the sky, it simply made it broken, where everyone had their own hole and their own piece of truth. And if the object is smart, it doesn't need to hide entirely. It just needs to make it so we can't synchronize. So that anyone who sees a stroke argues with someone who sees a dot, and both appear to be right. At this point, the communications department enters the conversation. They're not discussing physics. They're discussing the risk of panic, the risk to reputation, the risk of journalists using the phrase, different telescopes see different things. And this is where the conflict begins, which in such stories always decides the outcome. Scientists want more data and an honest narrative. Communications want silence and smooth language. Time is ticking, and the window is already closing. The decision is made quickly and inelegantly. Publicly, it's calibration, refinement, insufficient data. Internally, there's an urgent order to preserve everything raw, retrieve logs, document the chains, and not leak anything to anyone. Only one person on the call says what everyone feels but refuses to admit. If we start hiding the inconsistency now, we ourselves will become part of the experiment. It sounds like a reproach, but it's true. Because the strange thing about this hour isn't that the telescopes were wrong. The strange thing is that different instruments were able to simultaneously obtain different versions of the object, as if the object itself had divided the observers into groups. While they argue, another confirmation comes from the ground. Another major observatory is sending blank frames in the area where the object should be at its sharpest. Not a black screen, but a perfectly normal background. This is precisely what kills the nerve. If the frames were defective, they would scream with noise. If this were a pointing device, the stars would float. But the stars are there. The background is there. Only the object is missing. The result is a black window effect. The world sees the background, sees the telltale stars, sees everything except what the telescope was looking for in the first place. And this happens not just to one person, but to several. Someone tries to cling to something rational. Perhaps ephemeris has gone away. It's not where we expected. But this immediately breaks down, because at the same moment other telescopes see it where they should. That is, the object is simultaneously there and not there. For some, it's elongated. For others, it's a point. For others, it's not there at all. And all this in the same hour, with the same geometry, under the same moon. After this, people no longer discuss what kind of comet, they discuss who controls observability. And this is a key transition that changes everything, from the physics of the body to the physics of perception. Then a solution emerges that sounds like despair, but in reality, it's the only way out. A controlled experiment is needed. The object must be made to fail on different instruments in the same way, or appear in the same way. They choose the most stringent option, a synchronous series of short exposures around the world with identical timestamps, plus parallel radar monitoring, plus a spectrum on narrow lines. The idea is simple. If a subject is playing with a picture, it should give itself away in a place where you don't give it time to maneuver, where the frames are short, identical, and arrive in a bunch, and just when they're ready to launch this plan, a curt message comes through one of their key channels. The window is closed for today. The wording is bureaucratic, but the meaning is clear. Someone at the top decided it was better to receive nothing than to receive something contradictory. And at that moment, the scientists realized they would now have to contend not only with the object, but also with their own rules. Because if the object truly chooses its route, chooses the moon's screen, chooses the moment to turn on the false star, then the next step is obvious. It will try to choose our silence too. The closed window didn't arrive as a ban. It arrived as a sentence, worded dryly and carefully, so no one could point a finger and say, "You're banned from viewing." Formally, it looked like a postponement, like resource approval, like standard bureaucracy. But in reality, it meant one thing. At the very hour the data began to conflict, someone decided it was better not to have any new data at all. And here's where the story stops being purely about 3 ATLAS, because any system that begins to lift the silence over science does two things simultaneously. First, it recognizes that the situation is risky. Second, it itself becomes part of the observed behavior. If the object is testing how we react, then the prohibition on observation is a reaction it can measure. There was no hysteria inside, of course. There was cold anger and a desire to circumvent the restriction without completely breaking the system. The most unpleasant thing in such cases isn't the ban. The most unpleasant thing is that everyone understands. The ban didn't come out of nowhere. This means someone already has reason to fear what will emerge in the clean, synchronous data. They didn't cancel the short exposure plan, they simply tore it into pieces and disguised it. Instead of one large coordination project, they carried out dozens of small technical checks that didn't formally look like observations of the object. Somewhere, this was called a tracking test. Somewhere, a sensor stability check. Somewhere, a calibration on a star field in the target area. The wording varied, but the meaning was the same. Look in the same direction, but don't say you're looking in the same direction. And at that moment, a third line of evidence emerged, the kind that always comes to light in such stories, not as a discovery, but as a leak. Military radars. Citizen astronomy thrives on light. It sees reflected sunlight, dust, gas, and the beautiful geometry of a tail. Radar operates differently. It doesn't like comets because comets are usually fuzzy and too weak to produce a stable return. But if a stable reflection appears in radar, it immediately changes the class of the object. Because a stable reflection is either a dense structure or something that behaves like a structure. The first entry didn't surface from a report, it surfaced as a hint, an internal communications channel, a short message. There's a return, not for the model, no details, no numbers, but that alone was enough to make those who understood the phrase shrug their shoulders, because off-pattern means they were expecting a weak, shaky pattern, but got a repeatable signal. If you know where an object should be and get a repeatable return in that sector, then it's no longer atmospheric interference or random noise. And most importantly, such a signal doesn't fit well with the idea of a coma as a loose cloud. Some people see clouds, but radar needs density. Two things happen next. One is technical, the other is human. Technically, they're trying to correlate the return with the very hour when optics debated the nucleus's shape, and that's where the ugly beauty of coincidences begins. During the moments when some telescopes saw a dot, the return was more stable. During the moments when others saw a dash, the return either changed character or fluctuated in intensity, as if the object were shifting its orientation or reflectivity profile. Access is being cut off in a human-like manner, not because someone is malicious, but because radar data operates under different rules. Everything there is tied to security, to defense protocols, to the fact that excess noise in the public domain can create problems that cannot be resolved. And so, you see a classic pattern. Up to a certain point, data flows freely because it's just a comet. Then one word appears, sustainable return, and then a mechanism is triggered that doesn't depend on specific people. It operates automatically, access restrictions, publication delays, window rescheduling, incomplete sets. From the outside, it looks calm. There's nothing on the news. The object flies. People are arguing in the comments. But inside, everything is accelerating. Because now they have not only an image and a spectrum, they now have something that can hint at the surface geometry. And this is dangerous not because of science fiction. It's dangerous because of simple logic. If an object produces a stable reflection, it may not be a dirty snowball. It may be something with a shell, elements, perhaps even internal voids. At this point, the false star returns to history as it begins to look less like a strange light artifact and more like a component of a system. If there was a point source near the nucleus that was held relative to the object, then the radar may show a double profile, or a secondary component that appears and then disappears. And then they come up with a new hypothesis, so unpleasant that it is spoken only in whispers, without being recorded in documents. What if different cores aren't a processing error or a dust mask, but a configuration change? What if an object can change its reflective geometry? Not in the sense of split, but in the sense of rearranged its shape, or reoriented its elements, so that it appears one way to optics and another to radar. Yes, it sounds like science fiction. But they're not discussing science fiction. They're discussing the need to explain a set of facts that already exist. And those facts are a synchronous divergence of forms, blank frames against a normal background, a repeatable point source nearby, persistent reflection signatures and restricted data, and a systemic response in the form of access restrictions. Against this backdrop, a new layer of anxiety arises. Not what is it, but what does it do? Because if an object's behavior resembles observability control, then it takes the observer into account. And when you get to that point, you understand why the most dangerous thing isn't one weird shot. The most dangerous thing is repetition. Pattern. They saw Potter on the next technical window. This window wasn't as perfect as the previous one, but it was good enough to test one thing. If an object hides under a certain set of conditions, it will do so again. And he did. Not the same, not a copy, but recognizable. On some telescopes, the core again simplified to a point. On others, it again showed a stretch, and in one section, a time interval again appeared where the object seemed to disappear, leaving behind a background, Only now it happened faster. It was as if the object realized it was being targeted with a series of short exposures and began responding with short pulses, not disappearing for long periods, but blinking, making coordination more difficult. At this point, one of the engineers formulates the idea that will later become the internal name for the phenomenon. The object fragments us in time. It doesn't hide in space. It hides in synchronization. It ensures that everyone has the truth, but each person has their own. And worst of all, it perfectly matches the lunar geometry. The moon doesn't obscure the sky, but it cuts it. It cuts it in time, in available altitudes, in targeting capabilities. On such a night, it's impossible to assemble a perfect global grid, even if you really wanted to. If you're looking for the moment where history becomes truly dangerous, this is it. Because the choice from here on out won't be scientific. It will be a behavioral one. Continue coordinating and risk the target playing by our rules, or retreat into the chaos of isolated observations and thereby give it the perfect environment to maneuver. And then another line pops up. Satellites. Not because satellites see everything, but because satellites detect background effects that are difficult to fake. And if the upper atmosphere reacts along the Earth object line, this can be compared to radar windows and optical gaps. One of the analysts does something simple. He superimposes the timestamps of empty frames onto the timestamps of ionospheric bursts and onto the available scraps of radar data. And what he gets is worse than any hypothesis. Coincidences come in droves. Not every minute, not perfect, but enough to stop talking about chance. Enough to talk about script. And that's precisely why the order comes from above again. No coordination, no high-profile projects, no single public timeline. Because a public timeline is a gift for the facility. It's a timetable for our vision. But prohibition doesn't solve the problem. It makes it deeper. Because if an object truly responds to synchronization, then our refusal to synchronize is also a reaction. And this can be measured. The moon that night looked like an ordinary decoration, but to observers, it was an instrument that sliced the world into sectors. It didn't completely obscure the sky, it disrupted synchronicity. 1 hour, you're at the perfect altitude above the horizon. The next, you're already peering through a layer of atmosphere where the background flows, and any faint object can be lost on honestly without any mysticism. That's why the lunar coupling idea initially seemed like a convenient excuse. The geometry, they said, was inconvenient and everything was explainable, but the data contained something that geometry couldn't explain. After December 21st, the trajectory began to look like a detour, not because the object had turned, but because the flight path seemed to be choosing the worst location on Earth for accurate measurements. Inside, they called it something mild, suboptimal observability. In the hallways, they called it something more honest. He's walking on the dark side of our capabilities. The most disconcerting thing happened when someone did a simple test. They took the visibility forecast and the windows of large telescopes and superimposed them on the adjusted trajectory. The resulting image made me want to close my laptop. The best geometries for photography and radar were being bypassed, as if they were a plan. This doesn't mean the subject thought like a human, but it does mean it was in a place where it was harder to observe, and it repeated this behavior several times in a row. Against this backdrop, the false star ceased to be a strange point. It began to be viewed as a second component, firmly bound to the object, not a satellite, not a background, not a glint. It was held relative to the core the way a node is held, anchored to a common kinematic. If you have two bodies bound gravitationally, you expect one. But if the connection is rigid, without any noticeable drift, it already looks like a system. And then, for the first time, a phrase no one wanted to say out loud entered the conversation: double object. Not comet with debris, but two-component structure. Checking this with optics was painful because the optics were arguing with themselves. Some instruments produced a fine line, others produced a dot, and still others produced nothing. But the radar, even in scraps of classified data, gave a hint. The returns sometimes looked like two peaks, too close in time. It could have been anything, even just the peculiarities of rotation and reflection from the coma. But the coincidence with the false star was unnerving. And then that same black window happened, only this time it wasn't at the telescope level. It passed through the communication line. One of the closed channels where quick updates were exchanged simply went silent. No drama, no warning, no, we'll come back later. The silence lasted exactly 18 minutes. Not approximately, not around. Exactly as long as it coincided with the best geometry of the flight path. 18 minutes isn't an eternity. But in observations, it can be everything. It can be the only interval where an object reveals itself. When the channel returned, there was no apology. It simply stated, switching to backup due to technical reasons. And then a dry, issue closed. This isn't a mistake. This is a situation where someone has decided not to leave traces even within the system, because traces are starting to accumulate. Almost simultaneously, several major observatories released empty frames, normal background, stars in place, fields are smooth, object missing. If it had been a pointing error, the stars would have floated. If it had been the weather, the background would have been noisy. But the footage was too clear, and that's what drove people crazy. Because a clear background meant the camera was working, the telescope was looking, and there was no atmosphere interfering. Only the object was missing. Internally, it's called phonomask. This is an effect where a subtraction or processing algorithm removes what it considers unnecessary, mistaking the signal for noise. But the phone mask isn't synchronized worldwide. It doesn't select the same interval on different instruments in different countries. And here, the coincidence wasn't just a one-off. Here, the coincidence was a pattern that held its shape even after changing shooting configurations. NASA continued to speak calmly publicly. Nothing unusual. The object is within expectations. Data processing continues. But inside, they were no longer arguing about the beauty of the tale. They were arguing about why the object appears only when it's convenient for simple explanations. It's as if he leaves us with a version we can accept without pain, and removes everything else at precisely those moments when the truth becomes too harsh. And here the moon became part of the mechanics again, because the 18 minutes coincided with the section where the lunar geometry disrupted the global grid. For some, the object was low and faint at that moment. For others, it was higher, but close to the bright field. For others, it was on the edge of visibility. If you wanted to stage the perfect failure, these are the conditions you choose. Not total darkness, but a complex background to make everything look believable. And now, the main question was no longer, what is it? The main question was, who chooses the moment? Because if physics chooses the moment, the coincidences will be noisy and jagged. But here, the coincidences were neat, almost aesthetic. That same day, reports on the upper atmosphere revealed bursts that didn't fit the normal background. Not a global storm, but local bands. The stripes followed a line that coincided with the Earth object geometry at that moment. And that was bad, because it was no longer a camera. This already feels like an impact or a measurement, as if someone is testing the response and seeing where the planet reacts most strongly. In such conversations, someone always comes up with a simple thought that leaves you cold. If it's a scan, it doesn't have to be strong. Scanning doesn't have to be blatant, it just has to be noticeable to the person doing the measuring. To us, it might look like a strange background and random errors, and if the object really works this way, then its strategy is clear. It doesn't reveal itself directly. It reveals the environment's reaction to it. The false star was consistent with this. It could have been not a flashlight, but a marker, a reference point that maintains the system's orientation. And here's where the second component becomes more dangerous than any fantasy. Because if there's a node next to the core, it means the object has structure. And if there's a structure, radar relapse ceases to be a coincidence. It becomes an inevitability that's simply too difficult to acknowledge publicly. A new plan was being developed internally, not to catch a picture, but to identify a pattern. If failures are repeated, they can be predicted. They took previous disappearance windows, compared them with orientation, with the lunar phase, with the solar angles, and with the observation geometry. And we discovered another unpleasant thing. The dips tended to occur at moments when the object should have been at its sharpest contrast to us. That is, it went out, not when it was hard to see, but when it was easier to see. This is what killed all the calm explanations. They didn't expect the next failure to be a surprise. They began to regard it as an event that could be captured if they stopped thinking in frames and started thinking in rhythm. That night, no one said, what if? They said something else. If the pattern exists, it will repeat itself. This was no longer a debate about the nature of the comet. It was a hunt for the moment when reality would again become smooth and empty, precisely where the object should be visible. The plan was simple and wicked. Don't rely on a single large telescope that can be switched off or swamped by processing, but spread the observations across different types of instruments, optics with different matrices and different pipelines, radio, where the beauty of the image isn't important, spectrum, where background subtraction is different, and most importantly, private companies. Not because they're smarter than NASA, but because it's harder to simultaneously ruin them. An amateur doesn't have a corporate algorithm that decides what counts as noise. An amateur has a raw frame and an honest defect that doesn't match someone else's defect. They calculated the window based on previous black episodes. Give or take a few minutes, but that was enough. They created a range from this error and applied everything they could to it. Short exposures, long ones, time shifts, manual star alignment, so that later they couldn't say you were looking in the wrong place or the exposure was wrong. They didn't want a beautiful comet, but rather the moment when the comet disappears for no apparent reason, and for the disappearance to appear identical across independent data. And this window began so mundanely that it became terrifying. The frames were smooth, the stars were still, the background was clear, the core was visible. The false star, that same point source nearby, also remained in place relative to the object, as if someone had bolted it to the overall geometry. At moments like these, you want to believe that all this is simply the nervous fantasy of people who stare at the noise for too long and begin to see a face in the clouds. Then, without warning, there was a break. Not it got worse, not it went blurry, but a break. In the next batch of frames, the object disappeared, as if it had been cut out of the image. And again, the background remained perfect. There are two ways to cut an object out of a perfect background. Either reality stopped providing a signal, or the processing decided the signal was fake and needed to be removed. But the nastiest thing was that this time, the disappearance didn't happen in just one pipeline. It happened in three. Different ones, assembled by people who didn't trust each other. At the same moment, in one place around the world, an amateur got the wrong shot. Not with a beautiful tale or a sensational caption, simply a shot where the object disappeared from the larger ones, leaving a faint but persistent trace. Not a dot or a smear. Structure. Like a thin thread, very narrow, neither resembling a coma nor a tail. It persisted for several frames in a row, and most importantly, it didn't go in the direction that cometary dust usually flows. It was like a line, tied to the orientation, not the wind. Surprisingly, a second amateur, on a different continent, saw something similar appear in the raw frame at the same moment. It wasn't pixel for pixel identical, because the instrument was different, the sky was different, and the noise was different, but the meaning was the same. At the moment of the black window, a faint structural detail appeared in two independent cameras on the large telescopes, which shouldn't have appeared so synchronously by chance. This is where the fantasy ends, because chance can't be coordinated. This was what they feared most. Not something strange, but something strange visible in two places at once. This kills the favorite explanation of, you have an artifact. Artifacts don't communicate. They don't arrive at the same hour in the same sector of the sky on different matrices unless they have a common cause. And when they saw this pair of frames from the inside, no one said, wow. They said something else. So it's not disappearing. So we're disappearing. It's not the object that disappears. Our ability to see it in the standard way disappears. As if it can adapt to how we subtract background, how we calibrate noise, how we recognize structure, and it leaves a hole, precisely where our algorithms are sure everything is clear. At that same hour, the false star did something that shattered any hope of randomness. It didn't simply appear and disappear. It shifted. Not in the sense of drift by an arcsecond per day, but with a sudden movement that looked like a shift in position relative to the core. In one dataset, it would sit on one side, then, in the next block, seem to shift to the other. Not smoothly, not in orbit, but like a switch. If it had been a fragment, it would have maintained its momentum. If it had been a glint, it would have danced with the optics. Here, it looked like a marker changing roles. And then, someone said out loud what had already been hanging in the air. It's not a satellite, it's a beacon. The word was crude, almost childish, but it described the idea. A point source doesn't have to be a solid. It can be a mode. It can be a point at which an object makes itself visible in a certain range, so that someone who knows where to look can see the node, even when everything else is hidden. The most disturbing thing was that at this point, a connection with the upper atmosphere emerged. Those same local bands in the ionosphere, which had previously seemed odd, began to coincide with the phases when the false star switched. Not perfect, not mathematically beautiful, but enough to raise a question. The question was simply, if it's measuring something, is it using the node as a synchronization point? What happened next was what always happens in real bureaucracy when something appears that shouldn't exist. They started cutting corners. Not officially, not by order. Simply, we don't allow raw materials in this range. We'll publish in this range later. We need to double check the calibration in this range. This is a gentle suppression of data. It doesn't look like censorship, because censorship usually has slogans. Here, there are no slogans. Here there is silence and we'll check. But you can't stop a pattern by not publishing it. The pattern lives in the logs. And in the logs, a number appeared again, becoming familiar. 18 minutes, not a day. Not an hour, 18, just like before. As if the object knows it doesn't need much time, it needs a short corridor to pass through the brightest spot of our capabilities unnoticed. At some point, the artificial versus natural debate within us stopped. The debate became, does it react to us in real time, or is it simply using the geometry we create? Because if it reacts, then any coordination of observations becomes a signal for it. And if it doesn't react, but the trajectory is designed in such a way that we always end up in uncomfortable conditions, then this was planned in advance. And both options are bad, and here we return to the moon again. Because the moon doesn't simply obscure part of the observations, the moon creates a frame where Earth appears in sharper contrast as a target. When an object selects the Earth-Moon node, it selects a moment when, in the same geometry, the planet and its satellite can be viewed as a bundle. Not just 2 points, but a system. But This is convenient if you want to study interactions, or if you want to test what happens if you touch the medium between them. This idea sounds like science fiction until you realize that the gaps in the false star don't behave chaotically, they behave like a schedule. And the schedule doesn't have to be complicated. It can be as simple as breathing. Appear, disappear, switch nodes, disappear again. At some point, one of the engineers who believed more in the hardware than in theory suggested a trivial test. If this is affecting our algorithms, let's look without them. Let's use the most crude, the most stupid. They dug up old calibration methods and pulled out unsexy, unsightly processing tools. And with these stupid methods, the object didn't completely disappear. It became worse, weaker, dirtier, but not zero. And this was more frightening than complete disappearance, because zero can be attributed to an error. But a weak residual means the signal is there. It's just being eliminated by the smart methods we've come to consider reliable. In other words, it seems to play on our habit of cleanliness. We've taught ourselves to discard anything that doesn't look like a comet, and now the object takes advantage of this, taking on a form that our filters like to remove. At this point, the story faces a new challenge. If you want to catch an object, you have to abandon your usual standards of quality. You have to embrace the dirt, you have to embrace the noise, and the hardest part, you have to accept that the truth can look worse than the fake, because a fake is always beautiful, and true strangeness often looks like a mistake, and this is where the false star becomes key. It's beautiful, it's precise, it's clear to the eye, and it holds itself too firmly in relation to the object. It's like a hook sticking out of the fog, saying, there's a system here, and if this hook exists, everything else around it ceases to be just dust.